Thanks. So I'm very happy to be here today. I will be talking about a joint work with Jeroen Weinsberg on auditing, security, and data analytics for cloud stores. So first, who am I, who we are? So we are from IBM Research Haifa, from Computing as a Service, from Cloud Platforms Department. Actually, half of our department is in Haifa, and half of it is located in Ramat Achial in Tel Aviv. And I am from Cloud Security and Analytics Group. We are doing both more research theoretical work, and we are also cooperating with the new division of IBM Cloud and with IBM's Cloud on software. So come and join us and visit our website. Cloud storage. So today we are in the area of cloud. Whether you have public cloud, you're using public cloud with your smartphones and mobiles, televisions, video, pictures, everything, or your own premise, your own private cloud. So everyone is using the cloud nowadays. You either approach the companies, Amazon, Google, Microsoft, software, or open source such as OpenStack. So we have today a lot of data. Today we are in the area of big data. And big data, it's not only the amounts, but really the variety of types of data that we are having. We are having videos, tweets, images, mobile, everything is now on the cloud. And the way that is mostly naturally suited to store this data is using object storage. So why is object storage so suitable for the cloud? Because it fits for both structured and unstructured and semi-structured data. It's scalable. It can grow very fast. It can be accessed from everywhere, anytime. So what is object storage? So this is a storage architecture that manages data as objects, unlike a file system. So we assume that object includes data and metadata, and it can be accessed through RESTful HTTP, through REST API. An example for object storage is OpenStack Swift. So what is OpenStack? OpenStack is an open source software for creating private and public cloud, and its object storage is called OpenStack Swift. So you can see here this demonstration. So you have this REST API. The data is distributed throughout the system, and it's very scalable. It can grow very fast. I mean, in 2010, they discussed multiple petabytes, but of course today it is much more. The structure, as we said, it's not like file system. It has a structure of account, container, and object. And of course, there are replications in case you have some problems, in case you have some damage. Okay. Now, again, when we're talking about cloud, we are very much afraid from these security threats. What are the threats? What are the main threats that people are afraid of? So first, you need to trust your cloud provider. There is a problem of multi-tenancy. There are several tenants that share the same cloud resources, and we're afraid that there may be data leakage from one tenant to another. Of course, there is big data. It's very problematic to somehow manage and secure our data. There is problems that private data is sometimes stored in an unintentional. For example, you have an automatic backup of your mobile phone in your cloud. Sometimes you have some private pictures, and they go to the cloud as well. There are today privacy regulations that you must follow. So people are afraid of using the cloud. And in order to somehow provide security, you need to first understand what's happening in your cloud. In order to do that, you must understand the audit trail. So the audit trail is just auditing and understand all the accesses to the cloud. Who did what? Which IP address, what was done, which account, which container, which object, when it was done, and more information, failed attempts, resource uses, and latency. So However, this audit trail, I mean, even this simple line is, when you're talking about cloud, you're talking about big data. So this is from Amazon's official blog, 2013. In 2014, they didn't publish such numbers, so this is public numbers that we could took to this presentation. So then they published in 2013 that they had 2 trillion objects, 1.1 million requests per second. So if you count how many requests you had for 1 year, so for 1 year you have like 35 trillion log lines. Just keeping this audit trail, for 1 year, for 2013, you will need 10 petabytes. And this is really big data. And of course, I mean, when you're talking about logs, you're talking about semi-structured data. There is a lot of noise, lines are broken, error fields, etc. So again, big data, big junk, and you need to somehow clean this data. So now we are talking about OpenStack Swift. This is the open source we are working with in our cloud. So how does this audit trail of Swift log looks like? Okay, so user approaches the proxy server, and the proxy server goes to the storage server. So the request is, show us the object details of the goodbye objects in the Mark Twain container. User goes to the proxy server searches for the object in the storage server. You get the response, you get goodbye world, and this is the line you see in the proxy log. Basically, you see quite a short and easy line. So let's dive deeper into this line. We see that even if in this simple, quite short log line, we have a lot of information. We have the date and time that the request occurred. We have the client IP address. We have the request method. We have the path, which account, which container, which object. We have the HTTP status code telling us whether this request was satisfied or not. The number of bytes received and sent, the latency, how long this request took. And this is very useful to do some analytics. For example, we can use this logs file to understand, to make capacity planning, to obtain some insights on the performance, to predict failure analysis, when will our system fail, to design our system, to understand periodic versus unusual behavior, and of course for security and anomaly detection. So only inspecting these log lines is very meaningful. But as we said, even this audit trail is very big. We have big data. So in order to do such analysis, even of log files, we have to work hard. Okay, so the solution is, again, go to the cloud, go to cluster computing. And I will now talk a little bit about Apache Spark. So I guess Hadoop, everyone here are familiar with, or at least heard of? Yes, okay. So Apache Spark is an open source engine for large-scale data computing, like it is sometimes called Hadoop's next generation. It was developed in MPlab in Berkeley, and they say that it can run about 100 times faster than Hadoop. It also includes more libraries like SQL, streaming, machine learning, and graph processing. It can run either on Mesos, Yarn, standalone, in the cloud, can read any existing Hadoop data, can read data from HDFS, Hadoop Distributed File System, or from Swift. It's written in Scala language, and you can write processes either in Scala or Python or in Java. And it's built by a wide set of developers from over 50 companies. Since it was started about 5 years ago, more than 400 developers have contributed to Spark, and Databricks is the main company of the people from Berkeley that today stands behind Spark. Okay, so I will start by demonstrating a few examples of questions that we asked ourselves. We were asked about these logs. So we got logs from IBM's cloud, from IBM operational clouds, and we have a Spark cluster, and I will demonstrate some of the analytics problems that we faced. Okay, so one problem that we were asked is archiving. I mean, people from IBM Cloud came to us and told us, oh, well, we would like to build an archive for the object storage. If an object was not touched for a long time, maybe we can put it in archive. Somehow this will reduce us a lot of costs. So they would like to know how many objects they can put in the archive. What should be the planned archive size? A more specific question would be, what percentage of objects, for example, have not been used in the past 3 months? So here we have a big challenge. So first of all, this is a challenge of big data. We have billions, trillions of objects. What can we do? We have, again, we need to do cleaning and parsing of this data. Since this data is semi-structured, not all log lines are so nice. So basically, the techniques are using MapReduce techniques and sampling. So the B.Sc algorithm, we take the log line, take from the log line the data we need. This is the object name, the days that it was used, and the size of the object, and do some filtering to do the sampling, and do a reduce step that gives us the desired information. And this is, basically, this is the code I wrote in Spark. So see how simple it is, about 15 lines of code in Spark that answers the question above. Another question, maybe more interesting, is to use the machine learning library in Spark. We want to do a cluster analysis of client access to some account by time of day. This will allow us to understand the client's behavior, which times they are using the account, which times they are not. Then we can study the patterns and, of course, some unusual behavior, of course, and anomaly detection. So again, the challenges is that you have a large number of clients, and here there is an integration of both iterative MapReduce and machine learning clustering algorithm. So now the algorithm includes several steps. There is a map step. We take just the account, the IP, and the hour of day. We do some filtration, and then we do two reductions to find the vector of distributions and the clustering using the machine learning library. And this is basically the code in Spark. Again, about 15 lines of code, including the k-means algorithm. Okay. Another problem of community detection. This was done, these nice pictures were done using Spark and Datto, GraphLab. This is also an open source. There is some startup behind it. So it's very nice. So somehow, in the picture of the right, you see the data that you get. I mean, basically, in the middle here, you can see the account, and then there are the containers, and then the object. So, and then the client IPs, sorry. So when a customer comes to the cloud, the customer gets an account, and you don't know what happens inside this account. You know that he can generate containers, clients, etc. So this is a picture. But when we want to do some better refined analytics, for example, use machine learning algorithm and so on, then this picture is not good enough. So the picture on the left is just the same picture when you forget the account. So this is only clients of containers and IPs. And then you see that you have much smaller communities. You have either one container with several clients, or one client with several containers, or some communities that have a few clients and a few containers. So here you can really do something. You can do some audit trail, you can do some anomaly detection. Here, when you have smaller communities, you can start working. So this relates to our last activity, which was activity monitoring for OpenStack Swift. So you would like to have a complete audit trail of data access to Swift, activity monitoring, compliance reports, and not only to have reports, but also you'd like to define policies and enforce them. and really control data access to tell someone, well, you cannot access this container, you cannot access this account, you cannot make this. So of course there are solutions for databases. Such a solution, for example, is IBM's product InfoSphere Guardium that does exactly the same. And together with Guardium, we have developed a POC that connects OpenStack Swift with this. So this looks nice. I mean, if you can have Guardium to the cloud, why not? But of course, this will not work because still there is a scalability problem. I mean, the cloud is just too big to have these kinds of tools. It will never work in the real world, in real time. And we somehow need to identify which data is sensitive, which places exactly we need to put this monitoring, activity monitoring, and audit trail monitoring, etc. So we need to do some selective monitoring. So we need to use these big data tools, such as Spark, indicate, identify sensitive data, and also do some sampling or aggregation to see, or machine learning algorithm to see which parts of the data are sensitive and interesting, and then we can monitor them. Okay, so I think I will stop at this point and ask if you have any questions.